In this video, I will show you how to set up a rig for a stretching phone cord or any other type of stretching cord. So what I have right now, my phone's main geometry, the receiver's geometry, and the cord, and it is modeled out straight, sort of like a T-pose. I also have a master control for the whole phone. You can see it here. I also have a control for the receiver, so it can move around. That is parented under the master control. And of course I have an offset group to keep any icky values. The cord geometry I have separate in the outliner, just for now. So the first thing I'm going to want to do is create some joints for our phone cord. So I'm going to isolate selected here, and I'll take a front view. Now I'm going to switch to the rigging menu set here, rigging, and I'm going to turn on the create joint tool. So I'm going to start at the bottom of the cord here, and I'm going to use the snap to grid function, holding down the C key, or you can, oh it's the X key, sorry, or you can just toggle it on here. Snap to grid. So I'll start down here. I'll create about 8 to 9 joints, should be sufficient. 1, 2, 3, 4, 5, 6, 7. I guess 8 should be fine. I don't want to create that above, so I'll just place it right about there. Press enter when you're done. Now we have a joint chain. You can shift click on the plus to open it up. So ended up with 8 joints. I think that should be enough. And I also want to create 2 additional joints, one on the top here and one on the bottom, to attach our cord to the main phone and the receiver. So I'm going to turn on the create joint tool again, and I think I'll use snap to grid again, pop one here, and press enter because I don't want these ones to be part of the chain. I'll just scoot this down slightly. There we go. I'll create the next one right up top, and I'm just going to place it here. Enter. There. I'll place it just a little further along. Okay. Back at a perspective view. So these joints are not in the correct place, so I'll take all of them. Take that starting joint in the chain, scoot it over, there we go. And these 2 joints, I'll just scoot them over so that they match up with our geometry. There we go. And now let's rename these joints so that we don't get confused. So this will be cord and JNT for joint. So it'll be cord start JNT. Cord 01 JNT. I'll copy that name. Oops. Cord 02. Cord 03. There we go. There is our joint chain. I'll hide the geometry for a minute. So now that we've got our joints created, we need to bind them to the geometry of our cord. Oh, I'm going to select all of my joints, shift click on the cord, and I'm going to go to skin, bind skin, option box. Let's reset settings. To bind to joint hierarchy, closest distance, all these settings are fine. I'm just going to turn down the max influences to 4. Then we can apply and close. There, that's done. Now you can see, if you take one of the joints and rotate it, you'll see our cord will move along. There we go. Now we've got our joints bound to our cord, and that's great. but the animator should not be directly moving joints. So we're going to need to create something for the animator to use to move our cord. Oh, I'm going to just turn off the cord geometry for a minute here. Let's go into Skeleton, create IK spline handle, option box. One pops up on the side of my screen there. Let's reset the settings. So see down at the bottom of your screen, it's saying left mouse button to pick a start joint for the handle. Or let's change the number of spans to 3. Now let's click on our start joint here. Let's click on our end joint. And you will see in our outliner, we now have an IK handle, a curve, and an effector. Let's take our curve and isolate selected. Now we'll take a control vertex. Now if we move that, you'll see our joints will follow along. Great. Let's do a little bit of renaming to clean things up. Rename this to chord CRV for curve. Rename this to chord IK handle. And rename this to chord underscore EFF for effector. There we go, nice and clean. I'm going to do an incremental save. Now, we don't want our animators to have to move our joint chain by selecting the CVs on the curve. So let's create something to make it a little easier for the animators. Let's take our chord curve that is, and isolate selected. And let's go into control vertex mode. I'm going to select these first two CVs. I'm going to go into and use the create cluster tool here, or you can go to deform cluster, does the same thing. There we go, got our first cluster. Back into the chord, control vertex. Let's take our next CV, create another cluster. Take our next CV, another cluster. And we'll make these final two another cluster. There we go. Actually, I think I might want 5 clusters instead. I think 5 would do better. There we go, 5 clusters should do the trick for me. So now if the animator moves the cluster, it will move the chord, which moves our joints. There we go. Now let's create something to move our clusters a little more nicely, because these C's are kind of hard to select on the screen. So let's take a front view. Let's take our create joint tool. And I am going to hold down letter V to snap to points. There we are, there's our first joint. Let's create another joint, V to snap to point. I'm just going to move it up about into the middle of these two CVs. Right about there should be fine. To be right about in the middle of our chain. And I'll just do a Control D, duplicate, and move that one up to the top. There, those look to be about evenly spaced. Now let's do a little renaming. Chord start, control joint. I'll copy that to make my life easier. Oops. Chord mid control joint, and then chord end control joint. There we go. I'm going to take these clusters and I'm just going to group them. Chord, cluster, group. Now I want these control joints to control our clusters. So I'm going to take my autosave. Sure, let's autosave, why not? I'm going to take my first control joint This one is cluster number 5, so I'm going to take this one, cluster number 5, go to constrain parent option box. Let's check the settings. I want to make sure maintain offset is on, otherwise this cluster will jump to where my control joint's pivot point is, and I don't want that. So I'm going to just apply that. So now this control joint will control where that cluster is. I want this one to also control this second control joint, so I'm going to select that next, apply. I want my middle control joint to control this number 3 cluster, parent constraint, this guy, this middle one, parent constraint, and this guy to cluster number 1, parent constraint. Done. I can close that now. So now you will see if I move my control joint, I'm moving the clusters and the curve and the joints all together. So this will give our animator something to control a little easier. I'll also group these, Control G, chord, control joint, group. There we go, nice and clean. You'll notice we left these 2 joints out. We'll be using those later. So now that we have our control joints made, we need to create some controls that our animator can use to animate with. Let's go into the curve section. Let's create a NURBS circle. I'm just going to isolate selected on these little fellows and a NURBS circle as well. And I am going to create a group onto my NURBS circle to hold the transforms. Control G. Copy that name. Replace control joint with control. This will be our offset group. There we go. And I'm just going to snap this to the location of our first control joint. There we go. You can see this has transform values, however, this control is nicely zeroed out. And then let's just delete the history on it. There we go, no history. Duplicate this, move it up. This will be our mid control offset. You can see, no values, nice and clean. However, this does have values, but it's a junk group, so don't worry. Duplicate that again, up we go. This will be our chord end control offset, and our chord end control. There we go. And now we need to have these controls control the control joints. I know, confusing. So chord end control to chord end control joint, constrain, parent. Mid control to mid control joint, constrain, parent. Start control to start control joint, constrain, parent. Now we can hide these control joints. We can also hide the clusters. And now you see, we can move our controls to move our control joint, which moves our curve and moves the joints. Now you will notice we can rotate this way, but we can't rotate this way quite yet because we haven't set up the twist controls on our IK handle. Now, to be able to rotate our lovely joints, we can take our chord IK handle. Let's go into the attribute editor right here. Let's go into the IK solver attributes, open this up, and open up the advanced twist control so that we can twist our IK handle. Let's enable the twist controls. Now I'm going to make the chord geometry visible so we can see what we've got going on. Enable those twist controls. Let's see, ooh, we got a little bit of a wacky twist going on. Let's adjust these settings. Let's change the world up type to object rotation up, start and end. Our world up object will be our phone receiver controller. So let's find that. I'm just going to copy the name. And I'm going to paste this world up object number 2. And our master control will be world up object number 1. Enter. There we go. Our forward axis will be positive x. Our up axis will be positive y, which is going up. Let's just adjust our up vector. I'll just change this up vector to positive x, going down the bone. That's looking a little better already. And change up vector 2 to positive x as well. It's not quite looking right. Let's try negative x. Let's see if that looks a little better. Okay, so the top is looking better. Let's see about negative x for the top as well. There we go. So in my case, it's negative x for my up vector. Now that we've got our twist control set up, we've got a little more work to do. Let's take our chord curve and let's open up the node editor. Let's go to Windows, Node Editor. That's a bit messy. I want to display just the in and out connections of my chord curve. So I'm going to click the Input and Output Connections button here. A little bit messy, but that's okay. All we need is our chord curve and our chord curve shape. Let's move that out of the way. Let's press the Tab key to create a curve info node. I'm going to type in curve info. There we go. Here is our curve info node. I'm going to just rename this, keep things clean. Chord curve info. Let's open up the menu here. And to open up my chord curve shape node. And I'm going to open up the world space section here. I want to connect world space 0 to our curve info node, to other, sorry, that's on my other monitor there. And connect it to the input curve so that we can get the information of this curve. Let's take a look at the attribute editor. You see the arc length here? Let's take this number and make a note of it. I'm just going to copy it. Let's create another node. I press the Tab key, and I'm going to type in multiply divide. If I type in multiply, it should pop up here. I want a multiply divide node. I'm going to rename this node to chord stretch ratio underscore div for divide. This one's going to be dividing. This stretch ratio node will need to be set to divide because we're going to be dividing with it. We're going to need a second multiply divide node, so I'm just going to do a Control D to duplicate this guy, open him up, and let's rename it. This one will be chord scale normalized length div for divide. We do want this one set to divide as well. And now we're going to need to bring our master control into the scene. So I'm going to click my master control in the outliner here. And I'm going to click the little plus here to add that node to the graph. Where did it? Oh, here it is. I'm going to need that guy. Just going to drag him down here. Oh, looks like it's moved everything on me. So I'll just take my multiply divides, move them to an empty space over here. Let's open up the master control. We're going to need the scale X of our master control, or global scale, whatever your control's name is. I'm going to take the scale X, put up our normalized length, pop it into input 2x here. And we want our arc length of our curve info node to go into input 1x. There we go. So it is being divided by 1, which does nothing. So the length isn't going to change. Our stretch ratio here. we're going to pop output X of this node to input 1x of our stretch ratio node. There we go. This is the arc length, as you can see, 14.7 in my case. And I'm going to take this number, the default length of our curve, and pop it into input 2. Enter. So right now our chord is not being stretched, so the number will stay the same. Another node we're going to need, press tab, we're going to need a condition node. So you can type in a condition, just a standard condition node. Here we go. Let's open this guy up. I'm going to rename this chord stretch CDN for condition. The operation we want is greater than. So set that to greater than. There we go. I want my stretch ratios output X. We're going to connect that to the first term. The second term should be set to, thank you. The second term should be set to 1. So just type in a 1 there, done. And we are also going to connect the output X of our stretch ratio into the color if true R. Output X into the color if true R. There we go. So that is 1 right now because our chord is not being stretched. So the ratio is just 1. And we want to set the color if false R to 1. It's already set to 1, so no problem. Now we're going to take all of our joints except the first joint. So take all of these guys, and I want to add them into the node editor, clicking the plus here. There they all are, and I'm just going to scoot them to the side so they're not in the way, and up a bit. And I'm going to press 3 on my keyboard to open them all up. We're going to need these scale values of these guys. We're going to connect the out color R of this condition node into all of the joints scale X value. So I'm going to open all of these up. This is very tedious, which is why a lot of rigging artists learn Python. Do it automatically. So out color R will connect into scale X of all these, except the first node. So number 2 all the way up to number whatever, however many joints you have. And this condition node is basically telling Maya if the chord is being stretched, we want to scale the joints along X. And oh, that's all we have. I don't have so many. Let's see, 2, 3, 4. Sure, let's save. 5, 6, 7, 8, and the tip. We do not want to connect these to our start and end joint, so don't worry about those. That should be done. So if the chord is stretched, we will output the stretch ratio. If it is not stretched, we will just output 1 standard stretch. So let's test this out. Let's see if it works. I'm going to just minimize my node editor. And I'll take my end control here, and I'm going to move it. Looks like we've got a nice stretch going on. Good. And if I compress it, nothing happens. So I can stretch it to my heart's content, and you can see it gets nice and long, just like a standard phone cord would. Now let's do an incremental save. There we go, incremental save. Now let's do a little cleanup here. These 3 joints I'm going to put under my phone master control. There we go. So now when I move the master control, my chord will move. These 2 joints, I'm going to take the start joint. This one, I think we can just parent under the master control. However, I'm going to hide it so that the animator does not touch it by mistake. Pop that under the master control here. So now the start will also move. And then the end joint, I'm going to pair it under this control, the receiver control. I'm also going to hide it as well because I don't want the animator to touch it by mistake. Pop it under there. There we see it moves along as well. And it rotates. Now let's see if we can scale. Not quite. We still have a little bit of work to do. I'm going to show my geometry now. There's my geometry. So let's take our global scale control. Let's group our joints actually. Do a little cleanup. Chord joints group. And take all of these. Not the joints group. I can handle curve, clusters, and control joints. Chord, rig, group. And let's make a do not touch group. We'll call this do not touch so that our animator knows not to mess with this group or they will break the rig. Pop this in the do not touch group as well. And we'll put the geometry in the do not touch group. So we don't want the animator messing with that. Oh, where's the phone dial? Oh, I had it hidden. Okay, nearly done. We need to be able to scale our chord. Right now it does not scale. Neither does the geometry actually. So let's take, which I think this can go under the master control. Let's see. Oh yeah, that's fine under there. Okay, I'll leave it like that. So we're going to take our master control, going to control click on our chord joints group. Let's do a constrain scale. Leave on maintain offset. No, I think I'll leave it off. Let's add that. So now when this master control scales, everything should scale along with it. Let's see. Perfect. So now we have a scalable rig. Let's take our phone here. Oh, I think I parented something a bit wrong here. The receiver under the receiver control. Now, let's see. There we go, that moves along. Let's put this end control under the receiver as well. So now when I move this, the end of the chord should move. There we go, and it stretches. So now if someone needs to make a phone call, they can take the receiver, move it wherever the character needs to be, and the chord will stretch nicely. You can also take this control as well, just to give it a little control. Maybe they want to rotate it a little bit. And if the phone is too small for the scene, they can just scale it up. There. That wasn't too bad, was it? And now we can set all of this to 0 and everything should go back where it's meant to be. Now the last thing you want to do is hide all of these joints. So I'm going to hide the rig group, hide the joints. So now all the animator sees is the controls. And there's the phone chord set up, all done.